So far, we've looked at the parametric equation of the chord, we've looked at the tangent, so now it's time to look at the normal. So here, let's say we've got the point P given by 2AP, AP squared, right? We know that the tangent is going to be a line which just bounces off the curve, right, at that particular point. Then the equation of the normal, okay, or the normal itself first, is going to be a line which also passes through P, but it's going to be perpendicular to the tangent, right? So this is, of course, the normal at P. And now we want to find the parametric equation of the normal at P. So to start by looking for the equation of the normal, we need to know the gradient of the normal. And to find the gradient of the normal, we need to find the gradient of the tangent. So at P, right, given by 2AP, AP squared, we know that dy dx can be found by taking dy dp over dx dp, right? Differentiate y with respect to p over differentiate x with respect to p. So here, if I differentiate AP squared with respect to p, I'm going to get 2AP over. Then if I differentiate x with respect to p, I'm just going to get 2a. So the 2a's cancel out, and what I'm left with is just going to be p. So this obviously represents the gradient of my tangent at the point P, which means that the gradient of the normal is equals to -1 over P, since the tangent and the normal are perpendicular, and the product of the two gradients needs to be equals to -1. Now that we've deduced the gradient of the normal at the point P, we can come along and say that the equation of the normal is simply y minus y1 is equals to the gradient times x minus x1. Right, so it passes through the point P to AP squared, so it's y minus the y value here equals to the gradient times x minus the x value here. So in order to rearrange this into what we call the standard form, we're going to multiply both sides by P. So that's going to give us P times y minus AP cubed is equals to -x plus 2AP. I'm going to move the minus x to the left and the minus AP cubed to the right. And this is now going to give us x plus P times y is equals to 2AP plus AP cubed. And that's what we have for the standard parametric equation of the normal. And just like the parametric equation of the tangent and the parametric equation of the chord, the parametric equation of the normal is also standard bookwork. So make sure we learn how to prove this, okay? Because in 99% of the scenarios, we'll be required to do so during the exam. And the only time that we can use this formula without proving it is if the question tells us to write it down, or if the question gives us the equation of the normal explicitly. Okay, so that being said, this is how we prove the parametric equation of the normal.